The reindeer, Santa's trusted animal. They fly all over the world on Christmas night in order to deliver gifts. Now, how do they do that? First, let's start with the aerodynamics of a reindeer. A reindeer is not ideal for flight, so we need to make an assumption. We have to consider the entirety of a reindeer as a wing so that this next part will make sense. So now let's make our reindeers fly. If we want something to fly, we need the lift force to be equal to or greater than the weight of a reindeer. A normal reindeer can weigh around 150 kilograms, so we would need almost 1,500 Newton of lift for the reindeer to hover. But this is how lift is actually calculated, where rho equals air density, v equals airspeed, s equals effective area of wing, and cl is a lift coefficient. Since we considered the entire reindeer as a wing, s will be 4 meters squared. The lift coefficient for birds is around 1.5, so we'll use that too. Now, if we add this to the equation, we get that the minimum airspeed of the reindeer needs to be 20 meters per second. That's pretty fast. For reindeers, they would have to travel at 20 meters per second and create 1,500 newtons of upward force. Now, we need to know how much power that is required to maintain the flight. If we assume the efficiency to be 25%, the reindeer would need to have an output of 118 kilowatts of power, and that's just for the reindeer to fly. This is like the peak output of a Tesla Model 3. Okay, but the reindeers also need to carry the sleigh and Santa, so let's do some math and see where we get. First, we have this system: 8 of Santa's reindeers, Santa Claus, an empty sled, and a steady flight, which means no acceleration. When we mean no acceleration, this means that the total lift equals the total weight, and the total thrust equals total drag. So, if Santa weighs 100 kilograms and the sleigh weighs 200, then the mass of the entire system is around 1,500 kilograms. So, we're also going to make sure to set holonomic constraints. This basically means that we won't allow any degrees of freedom, or basically no rotation of the sleigh or anything else. So now, the weight of the entire system is almost 15,000 Newton, which means we need 15,000 newtons of lift. Using the lift equation, we get the speed needed as 22.4 meters per second for each reindeer. This is about 50 miles per hour. Now, if we use a drag equation here, we get the drag as 460 newtons, which means the thrust needs to match that. If we can assume the efficiency to be 25%, the power per reindeer is 165 kilowatts of energy, which is as much as a Volkswagen Golf GT. These reindeers must be eating some really good food to go this fast. When we look at the power of the entire system, it's 1.3 megawatts. That's as much as the EMD SD70. Santa, if you're watching this, I got a few tips for you to maybe save a bit of energy. First, maybe add a few gliders to help you save energy. Then, I would recommend adding actual wings to your reindeer. Santa is really lucky to have these unaerodynamic reindeers. I hope you guys enjoyed this video. If so, make sure to leave a comment down below about what you would want for Christmas, and subscribe if you enjoy fun physics. Be curious like a child, the world needs more of it. Bye!